Great. Thank you, Erica. Nice to see everybody. It's the end of a long day. Congratulations for being here. I'm probably between you and your Thanksgiving vacation, so I'll try to keep this light and airy. This is the work of a very talented PhD student, Adam Levertu, who is actually here. Adam will be able to answer questions because I'm giving a talk about the work of another student right after this, actually one who works with Adam. And I'm sure it's very stressful for Adam to hear me talking about his work. So I'll look to him every now and then, and I've told him to shout out if I say something that's absolutely offensively wrong, which will happen for sure. So we're talking about real-world drug and adverse reaction lexicons derived from Reddit. So my lab focuses entirely on drugs and drug response, and many of the traditional sources of information about drug response, such as what Nigam was just talking about, comes from the electronic medical record, from clinical trials. But the idea now is that maybe we can get this information from patients directly in their own words. The problem is their own words are not the words of medical professionals. So we have to learn what patients call their drugs and what patients call their side effects or their adverse reactions to drugs. And we decided that Adam decided that Reddit would be a good source, and he convinced me. We're particularly motivated by the opioid epidemic because we think that that in particular needs to be monitored really almost in real time, and that many of the existing methods for monitoring drug use and drug overdose and the opioid epidemic in general are lagging too far behind, so that when the derivative is very big, they are not good indicators. This is just a graph that shows the overdose deaths involving opioids from 1999 to 2017. I'm sure you've seen graphs like this, and it just has continued in 2018 and 2019 on this upward trend. 30% of patients prescribed opioids misuse them. 80% of people who use heroin started as prescription opioid users. And this is a terrible epidemic. And the question is, should we have seen this coming? There are many existing methods for drug surveillance. One of them is NDEWS, the National Drug Early Warning System. It comes out of the National Institute for Drug Abuse at the NIH. And it's a federated set of medical systems that watch what's happening in their EMR, pool data, and look for signs of signals. Unfortunately, they're not always timely, and even they have mentioned that they're starting to look at sources like Twitter and Reddit for more up-to-date information. There are also curated lists of slang terms that you might think would be useful when you look at Reddit, Twitter, Facebook. These are the terms, so clonazepam or Klonopin, which is a very famous benzodiazepine. We know that it could be called benzos, K-pin, supervalium, tranks. But what I'm going to show you in a few minutes is we have about 200 or 300 other synonyms that are not on these expert curated lists. First of all, I always wondered what it would be like to say to somebody, I'm an expert on the slang terms for drugs. There are a lot of experts who might not be medical professionals. And then the same for alprazolam or Xanax. That's actually the one I'll show you. Very colorful names like bicycle handlebars, bicycle parts, bricks, footballs. I'm sure you know all the synonyms for alprazolam or Xanax. And of course, many opioids. So as we like to say, there's this gap between the controlled terminologies that we would love to have this data in, that we use in our informal medical records and in medical coding, and the world of patient-derived data. And we're trying to bridge that gap, but even despite some of the efforts like the ones I showed you for the expert annotated lexicons, we don't always get all the way across. So Adam fixed this using natural language processing and public available data in Reddit to mine both drug names and adverse reactions. And I want to tell you a little bit about how we did it and then some of the fun findings and applications. And then previous efforts are limited. I won't focus on that. We used something that you may be familiar with if you're a data science person. It's a word to Veck, which is a way to take words and understand what they mean by looking at the words that surround them. It's a good idea. John Firth in 1957 said a word is characterized by the company it keeps. And so we can take words and we can encode them in fixed length vectors that basically summarize the sets of other words that they're around. So you can imagine that this would be very useful for discovering synonyms, because if true words really are synonyms, they should be surrounded by very similar words. It allows these mathematical approaches and the application of modern machine learning. So we're going to train these are called embeddings, when you go from a word or any kind of concept to a fixed length vector. Very hot topic in computational sciences these days, and it's called embedding. Available word embeddings do exist, but they're limited. Adam and I would have loved to use somebody else's embeddings, but medical terms are different from other words. They're rare. Many of the methods were not optimized for performance on the kind of text generated by real people. They often missed short phrases because they were literally only looking at words, and sometimes you need to look at phrases. And they are often generated from high-quality data sources, which is normally a good thing. But when you're worried about misspellings, slang, stuff like that, you actually want the noise because you want to learn on the noisy data, which is what you're going to be getting from patients. And so we think that with this approach, we can look at drug usage in Reddit and drug discussions on Reddit with better temporal resolution, perhaps with finer precision, and see things that doctors in the medical system don't see. So Reddit data is perfect because it's low quality data. This is my favorite part of the talk. It's not curated, it's low quality, it's filled with misspellings and slang, it's redundant, it's generated by the lay public. In short, it's perfect for this work. And if you don't know Reddit, it's this website which is organized into discussions, and it's highly branching. You can discuss almost anything on Reddit, and there are many parts of Reddit that are devoted to health, including r/health. They're always r/something. So there's r/fast cars, r/good food, r/health. So that's what we focused on. And if you look at Reddit, you can see plenty of mentions. This is in thousands. More than 700,000 mentions of marijuana, heroin, cocaine, all your favorites. I don't mean to presume. And so that even for the drugs that we use as prescription medications that are not addictive, there's going to be plenty of signal of people discussing how their heart medications are working, how their antidepressants are working. But certainly you could see why this got our attention for drugs of abuse, because they are actually specifically enriched in this corpus. So the general approach is we downloaded, and when I say we, I almost exclusively mean Adam, downloaded all the Reddit data that we needed. We did discover there are software packages that allow you to not only look for single words, but look for multiple highly reoccurring pairs and triples of words, so you can get short phrases. That turned out to be quite important. We do this embedding task, which I won't go into the technical details. We did a continuous bag of words for those of you who do this kind of work. Then we had vectors for all of our words, and we could put them in a vector space, and we could have a lot of fun looking for synonyms. We had to do a little bit of clever filtering because of some technical issues, but in general, we got to where we wanted, and I'll show you kind of what we found. First of all, there was 2 billion comments over just 2 years. We took this health subset, and this was about 200 gigabytes of data. We had a couple of gold standards we could use to see how we were doing. One is a clinical term similarity ranking that's done by humans, where they gave humans pairs of words and said, how similar are these? And so that's kind of a gold standard of similarity. And then there's a database called Drug Bank, which gives a lot of official synonyms for drugs, and we could see how well we reproduced those. So those were our two main metrics. Adam showed that tuning the parameters was quite important. So the default performance, this is a whole bunch of different parameter settings for the Reddit corpus. And you can see that it ranges from, the best performance would be in the upper right corner. And if you just take the default settings for the embedding software, you get something in the middle with a performance around 55% on these two gold standards that I mentioned. But if you optimize, you can get up to almost 70%, where you're doing very well on the drug bank synonyms and very well on the expert curated synonyms. So we, of course, took those parameters, and you can also do very, very poorly. And so this was kind of a technical contribution of the work, telling people that they do need to pay attention to the parameters. Interestingly, when we took the performance on the expert curated synonyms, when humans were asked to do the same task, they were only a little bit better than our best Reddit performance. So humans were at 73%, we were at 67%, and then things trained on the health record, or at least one thing trained on health record, was only at 44%. Something trained on PubMed, which is filled with official words but is not filled with unofficial slang, was down to 40%. And then again, Twitter and Google News, when not trained super thoughtfully, I mean, it was somewhat thoughtful, but wasn't perfect, get really not very good performance. So we were pretty happy with that. Here is a distribution. So we take oxycodone, a very famous opioid, and if we look for all the words that are similar to that based on the cosine distance, the angle between them, where small angles means that they're close, you can see the blues are, I think, curated, known synonyms, and then the orange is kind of the baseline. And so you can see there is some overlap between the baseline, not oxycodone, and some of the synonyms. But we took a pretty strict cutoff and said we're going to call everything to the right of that red line, we're going to call that a synonym of oxycodone. And I think I have some for you. So there's oxycodone, there's some misspellings. With that pretty strict 0.77, it's everything above the red bar. But below the red bar, there are intriguing things, and that led us to tweak the algorithm a little bit to get more synonyms. I promised you I would show you alprazolam. This is one of my favorite slides. Here's 184 high-scoring synonyms for alprazolam. And Xanax, Xannies, Xanny, and that's where they occur on this list. One of our favorite things, and I'll stress this later on, is somewhere in there are the actual tags that are put on the tablets. When you look at a tablet, it sometimes has some numbers on it from the manufacturer. People who really care know those numbers, because when they're buying something, for example, on the street, you check to make sure it has the right numbers on it so you know you're getting the right stuff that you're buying. So in general, we were very pleased because when you looked at the drugs, we had 1,300 drugs, which led to 4,000 known terms previously, and we identified an additional 13,000 slang, misspelling, etc. Same with adverse reactions, where we found a whole bunch of new terms. So we can map now from a word like vomit, which might be the formal word in the terminology, to, forgive me, barf or whatever as a slang word that might appear in Reddit. Now Adam validated this in many ways. He looked for exact matches. He looked for obvious misspellings, phonetic overlap where the words would be pronounced similarly, pill impressions. This is what I was telling you about those numbers. There's, of course, the Urban Dictionary, which is an online resource which has slang in it, so he could look there. And he also just did Google searches and saw, if you search for alprazolam, what do you get in the top hits, and are any of those top hits containing text that matches your proposed synonym? So there is an example of oxycodone, which has A51 on the pill, and A51 came up as a synonym. And we didn't really understand why initially, and then it became clear that we were picking up all these pill impressions, especially for the drugs of abuse. We also saw the phrase barred out, and it turns out that in the Urban Dictionary, barred out was used as a synonym for Xanax, or alprazolam. Okay, so that worked out well, and we were able to add a lot of misspellings, a lot of pill impressions, and as you saw, thousands of other synonyms. So you might say, well, does this really make a difference in terms of the kind of downstream data mining that we're going to do? Remember, we would like to try to, for example, monitor use of drugs, monitor the mentions, also associate drugs with new side effects. Well, it's pretty big. If the known names are in purple, And then the synonyms are in light purple, slangs and misspellings. You can see that for some drugs like nicotine, marijuana, we're getting a huge add-on. For other ones like kratom, everybody just calls it kratom, and there's very little that we added. But on average, we added a lot. And so we published this. It's available to anybody who's now mining any kind of lay person generated text, and we hope people will use it. And of course, we're going to use it. I'll tell you a little bit about that in a second. We did have some failures. It's discussed in the paper. I'm not going to focus on it because it's the Friday before Thanksgiving. Why talk about failure? We also generated this spectacular picture. So this is a two-dimensional projection of all drugs onto a two-dimensional space, of course, where we've grouped some of them together. So, for example, all of the opioids are up in the top in purple. So you might be able to see them up there. There are cancer medications that are kinase inhibitors, a whole different class, down on the pink level. And then we actually got some plants and flowers and stuff which are interesting because some natural products are used as drugs, and so you kind of can see why they would be there. So the last story I want to tell is the other half of the story, which I'll only tell in a third of the time, which is adverse drug events and our ability to distinguish and to detect and distinguish them. So we care about adverse reactions because we'd like to discover new ones. We think that the patients are probably telling us about new side effects that doctors in the medical system have not previously discovered. And we also think that this would be a way to follow the opioid epidemic indirectly through some of the things people might be saying about the experiences they're having with side effects. Now, previously, I had a postdoc in the lab who came up with a ranking. One of the big problems is ranking the severity of side effects. Nobody really cares if a drug causes a mild rash, because it's just not a big deal. I mean, the person who has the mild rash may care, and so I really shouldn't say nobody cares. That's not fair. It is not a reason to have a medical emergency or to put a lot of resources into it. However, if a drug causes a severe side effect, then we should probably pay attention to it because it might have great expense both to the individual in terms of money, lost time at work, and medical problems, as well as society. And so my postdoc wanted to estimate the severity of about 3,000 side effects, and he actually used Amazon Turk. He paid people online to take pairs of side effects and tell him which one is the worst. So we had about 2,000, 3,000 humans who looked at pairs of side effects. We paid them like $0.25 per comparison. And at the end, we got all this data that allowed us to get a rough idea of which side effects, like suicide, heart attack, were very bad, and which side effects, like mild rash, were not so bad. That was good, but it was expensive. It only covered 3,000 side effects, and it was a good start, but we thought we might be able to beat it. So we did the same trick. I'm going to skip this. As I said, there were some limitations. We had 2,500 crowd workers. We had to pay them. It took 150 person days, and there are 15,000 adverse events that we're aware of, but we only had the resources to get a ranking of 3,000 of them. So then Adam had a great idea, which is he took the ADRs, he did the same trick that I showed you for the drugs. So imagine the same kind of graph with all the points showing not drugs, but different types of side effects and all of their synonyms embedded into a two-dimensional space. In other fields, they have done some interesting work in the area of sentiment analysis, like do people think something is good or bad? And one of the ways to do it, if you can see it in the upper right there, is you take something like love, which is in the upper left, and something like hate, which is in the lower right. And you say, okay, we have something that people tend to like a lot, and people that, in fact, they love it, and something like hate, which is very negative. And then you do a walk from hate to love and check where all the other concepts in between lie in terms of, are they closer to love, which is positive, or are they closer to hate, which is negative? And that allows you to rank all objects in the space with respect to how positive or negative they are. So Adam's idea was, we know some really bad adverse events, and we know some really mild ones, both from the previous work of my postdoc and also from common sense. So let's use those as the love and the hate, and then let's rank all 15,000 side effects based on where they lie between the two. So he did this. I think I have a picture. So there you have severe side effects in red and benign side effects in blue in this projected space, similar to the ones I showed you for drugs. But now these are adverse events. You do random walks from red to blue to just see what kind of sites get visited and how close what nodes are visited, the black ones, and whether they're mostly closer to red or closer to blue. Then you can color everything on a scale from red to blue in purple. And then you can get, for every object in the network, you can get an estimate of the severity, with the most severe on the right, the least severe on the left, and you can see a big mountain of average severity with pretty good resolution. So first of all, when we went back to the 3,000 that my postdoc had ranked, very good agreement, correlation of 0.7 almost. That's only for 3,000, though. We did 12,000 plus synonyms. And so here's one of my favorite pictures. We took this simple concept of abdominal pain, but then took phrases of abdominal pain, such as minor stomach cramps, extremely painful stomach cramps, upper abdominal pains, and we mapped that onto the space. And what I really like about this is, even for this one symptom, abdominal pain, we're able to spread it out based on the modifying text that allows us to tell which ones are minor, which ones are major. So we feel now that we not only have a way to recognize ADRs, but we have a way to estimate their severity. So now, working, for example, with the FDA, we have a discussion with the Food and Drug Administration about looking for unrecognized side effects that are mentioned either in social media or even in official FDA documents, but they didn't realize these are severe and we might want to pay more attention to them while we're following the use of drugs. So we've predicted a bunch. In another project, we predicted a bunch of drug-drug interactions. We literally predicted thousands and thousands of interactions, and now we know which ones to focus on, the ones that are getting really high severity scores. And you can not really worry about the other ones. We believe that they're true, but they might not be significant. So that's one example of how we're using this severity ranking for useful applications in the discovery of drug-drug interactions, which, as you probably know, are a huge cause of problems in medicine. People are on 7-8 meds, and they can have interactions that cause more problems than the disease that they're treating. So that's my quick Thanksgiving story. I want to thank Adam for his incredible efforts. I apologize that I won't be able to stay for questions, but Adam is here, and I'm sure you're all tired, and I want to give you that flavor of how we're using kind of these modern data science tools to approach real-world problems in health, medicine, and drugs. So thank you very much.
Thank you, Russ.
It's been a very exciting day.
I think it was exciting 2 days as well, and I think you are right, too, about the Friday afternoon before Thanksgiving. So with that, I would really like to thank everyone who participated at this event, faculty, students, our members, our prospective members, our special guests. I'd like to thank Jason and Malwana, who are out, Malwana, who's out front, who have helped coordinate this event. And we look forward to hearing from you, maybe after everyone gets done with their travel and enjoys Thanksgiving. So thank you all so much, and I hope you have a good weekend.